To continue converting our interpreter to object-oriented style and deal with the value data type, we need to use this new encoding of objects. And that's because values effectively have two methods on them. A value will need a number method on it because we use numbers in num_up. We have effectively a type case or a dispatch on the variant of the value here to check whether it's a number or not. And we do that because we're really just trying to get the number out. So we can have a number method that responds by producing a plain old number from the value. The other place we use values is in the implementation of application. So in application here we have a type case of value to deal with closures or not closures. So let's add that method as an apply method. Apply of a value takes an argument to the value, an argument to the application, and then if it's a closure, then it applies the closure, evaluates the body to get a new value. Now it turns out in this case that the number method really only works with num_v's and the apply method really only works with closure v's, but to be consistent we have to add the method to both kinds of values. So when we're making a number v given some number, we should get back a value. That value has to be, how are we going to combine these things? We put them in a list with tuples to pair the names with the values. So this is kind of a pseudo type up here. Of course we have to be in the untyped world to make this work out anyway. So we want to construct a value as a list that has a number method. Number method takes no arguments. How do we convert a num_v to a number? By just returning the n that was given to the constructor. The apply method takes a value for the argument. Let's call it arg, since it's the, well, let's call it v as the argument that we're applying to. But if you try to apply a number, then what our interpreter did was it said error interp, not a function. So that's what we want to do in this object as well. The closure case, a close v, takes an argument name, that's a symbol. It has a body expression, and it has an environment inside. That makes a closure value. And in a closure value, the number method, if you try to add a closure to another number or multiply it, then we get an error again. That is the not a number error. But the more useful method on closures is the apply method. And that's where we get a value for the argument to the closure. And our job is to produce a new value by evaluating the body of the closure with that argument. That is, we want to interp the body in an extended environment where we bind the name arg to the argument value v, and the environment we extend is the one that's in the closure. And the only thing we have to fix here is that we don't need to use the interp anymore. Body is an object expression that we can interp by just applying it to the function, applying it as a function to the extended environment. And with that, we've replaced our value data type completely. We have number values and closure values, and if we wanted a new kind of value, then we wouldn't change any of this code. We would just describe how it behaves for numbers and application and so on. Like if we added continuation values, they would do something useful in the apply method. We can try to run our tests. They're not going to pass, partly because I haven't changed appv, right? Instead of taking this value and doing a type case, I should take this function, and I need to call its apply method. So how do we find the apply method? Let's get a lookup function to do that, or rather a find function to do that. So find is going to take this object, produce this value produced by evaluating the function expression, and get its apply method out, and then we need to apply that method to the argument value, which is the one here. All the other code goes away because that is moved in the two different kinds of objects. A closure value does its own application, and numbers do their own error raising. So that's one place we have to fix. Another place we have to fix is, well, we have to add the find function, but the other place we have to fix is in num_up, where we used to dispatch on the type here. We instead just apply the operation to, we need to find for the left value its number method and apply it. and find for the right object its number method and apply it. And the only thing missing is the find function. I'm just going to grab that from over here and paste it in. And then we'll be able to run this code. Our test won't actually pass. And that's just because, let's look at the test that fails. On line 142, our tests are comparing an object that we get back from interp with an object that we construct with numv. Both of those objects are lists of values that have functions in it, and that's where the problem is. We can't just compare two functions. So what we have to do is change this to do a find of the number method, and then we can call that number method and see that we get the number 2 back. And now if we rerun, then we should find that this first test passes. And so now the first failing test is 146 down here, where we have the same problem again. So we would have to change all of our tests to do that. It's a little bit tedious to write find everywhere here and add the extra parentheses. So what we would actually do is introduce a macro called send that does the find and the application for us. And then we change all of our tests to use send of the result of interp, get a number back, and see whether that's the number we want.